Hello and welcome to my Cisco Netacad Introduction to Networks lecture series. As of 2024 December, this is lining up with Module 3 of Netacad Introduction to Networks. In this video, I'm going to introduce two models that are used to explain and implement networking concepts and protocols. We're going to do a lot of focus on protocols here, but the two models that we're going to focus on are the TCP IP model and the OSI model. So here we have the OSI model and the TCP IP model side by side. You'll notice the OSI model has 7 layers. The TCP IP model has 4 layers. Some of the layers match up with each other, and I've color-coded them if they do, so you can see the application layer called the same thing. Then we skip down here, we've got the transport layer. The network and internet layers are called something different, but they cover the same protocols. And then down here, everything that's in the data link and physical layer of the OSI model is covered in the one network access layer of the TCP IP model. And I want to point out again here that the TCP IP model that we're using has 4 layers, but just to make this a little bit more confusing, in the wild, you might see a 5-layer TCP IP model, but I'm only going to show you our wild TCP IP model just has the 4 layers. So there it is in the wild with its 4-layerness. If you see it with 5 layers, don't freak out and think that you learned something incorrectly. You did not. Some people use a 5-layer model for the TCP IP model. For now, we're going to set aside the OSI model. So we're just going to set it aside. It has 7 layers. We're going to focus on this 4-layer model first, which is the TCP IP model. For both models, the one thing that is really key is that you understand the theory about how packets are encapsulated, and then the transfer of data. You've got to think about it in your mind. It doesn't happen exactly as it shows in the protocol stack, but it's close enough to give you a good understanding of what happens. So you have your encapsulation as a packet moves down the stack, and then you have the transfer of data, and then as the packet gets to its destination, you have your de-encapsulation of the packet. And by thinking of the model that way, it will help you to understand how this process works. So within each layer of the TCP IP model, there are protocols that are associated with each layer. If you're using Netacad, it just mentions all of the protocols. Like you already know what they are, and you probably don't, or possibly you only know some of them. So then it gets very confusing as to where to put them in the protocol stack because you have no idea what that protocol does. So we're going to talk about some of the protocols, mostly at the application layer and the transport layer for this video. Starting up at the top, right? This is the top is up here at the application layer. This is the layer that you're probably most familiar with, or most people are probably most familiar with, because applications are something that people deal with every day. It's the way you interact with the computer in most cases. Certainly you're familiar with email. That belongs at the application layer, and also using a web browser, going to a website. Both emails and web services reside at the application layer. So we're going to start with one that you're familiar with. Now you might not know it by this name, but it's HTTP and HTTPS. This is the web service. So if you're just starting on your tech journey, you still, no doubt, you've used web services. You've gone to Amazon.com you've gone to google.com. Currently, those are all based on HTTPS. The S stands for secure. HTTP is the original protocol. So when you do that, you are just using HTTPS to transfer information from whatever web browser you're using, such as Internet Explorer, and the web server you're contacting, such as Google. Okay, so here's a protocol at the application that you may not know about. Many people don't know about this one. So when you go to a website like Amazon.com or catoftheday.com, you're not actually going to that name. No, everything goes by an IP address. You can do a trace route to see this in action. And so let's go ahead and do that. Okay, so right here from the command line, we can type in, so you use the command in Windows trace RT, trace for trace route. And let's say we want to do google.com. Now it's going to, very first thing it's going to do here is resolve google.com to its public IP address. And that's what's important here. We're going through hops down here for the packet to get to the server. But the important thing that we want to note here is that google.com, its location is by IP address. And DNS, the domain name system, which is sometimes called the phone book of the internet, right? It's at the application layer, and it does this thing where it resolves or looks up the IP address based on the web URL that you type in, right? So google.com, the name of the website, is associated with its IP address. And that's what DNS does. You need to just know the name, DNS, that it stands for Domain Name System, and that it looks up IP addresses based on the domain name. Okay, that's it for DNS. Email, you all know email, right? Email also resides at the application layer. But what you may not have heard of is SMTP, POP3, and IMAP, which are the 3 email protocols. So you thought you knew email. Oh, emails can be easy. I know it, but maybe you haven't heard of all of these protocols. So these 3 protocols are all email protocols. They all reside at the application layer, the top of the TCP/IP stack. You have to learn and remember these and memorize where what they do. You have to memorize what they do. So SMTP is Simple Mail Transfer Protocol. That's what it stands for. And it has to do with the sending of emails. Okay. POP3. POP3 stands for Post Office Protocol 3. This is not really in use that much anymore. You can set your email service up to do this, but most people don't. What POP3 does is it downloads the emails from the email server to your device, and then they're stored locally on your device, but they're deleted from the email server. So most people don't do this anymore. This is the way email used to function originally. I still have my original AOL email. I do. It's crazy. I keep it because I send all of the junk stuff that I sign up for to get discounts. I send it to that email, but I still have it. Anyway, it doesn't function like a POP3. email anymore. But if any of you ever watched When Harry Met Sally, that was like, you know, emails all download to your computer and you can read them. You've got mail, but they're gone from the email server. So that's POP3. IMAP is probably what you're used to with the IMAP, which stands for Internet Message Access Protocol, IMAP. This is where the emails just stay on the server and you can access them from anywhere. So you're on your phone, you can read your emails. You're sitting at a laptop at Starbucks, you can read your emails. You're on a college campus, you can read your emails. They don't disappear. You don't have to download them. You get the idea. So how are you going to remember these three? Because you have to memorize this. Here's one way you can do it. It might work for you. SMTP stands, this begins with the letter S. That's what I'm trying to say. Begins with the letter S, which sending. SMTP has to do with sending emails. POP3. Well, pop art. I don't know if you're familiar with pop art, but like there's a famous Marilyn Monroe. I did a AI generated pop art here with some old computers. Pop art. It's old. Well, it's older than the internet, right? But it's old, but maybe you can remember that pop art is old. And so POP3 is the old protocol where you used to have to download your email to your local device, and then it was deleted. And then IMAP, I think you can think, I use IMAP. I use IMAP. Yes, I have access to my email across all my devices. And any computer that I sit at and log into, my email is there. Lucky. Yeah. Okay, moving on with the application layer. Remote connections. So students sometimes get confused with this notion of a remote connection. Look, I need to move that for a second. When I say a remote connection, I am not talking about being in the middle of nowhere with no internet. No, I'm talking about you don't have to be standing right next to the device. Here I am. Oh, here I am. Oh, wrong side. Here I am. Over here. Here I'm standing sitting right next to these switches in this router, right? And so to connect to them, I'd have to plug in a console cable, which we'll get to later. But I don't want to do that. I don't want to always have to go to the device, to plug into it, right? I want to sit at my desk. A lot of times switches, they're actually just like stuffed up in ceilings and whatnot. You don't want to have to get a ladder, take out a ceiling tile, bring a cable with you, no, you want to sit in the comfort of your office. Two types of remote connections, Telnet and SSH. Are there other remote connections? Sure. But we're going to focus on Telnet and SSH. They're at the application layer. And we'll get into more details on these later. What you have to remember for now is that these are ways to access devices remotely, and they reside at the application layer. Okay, finally, we've moved out of the application layer into the transport layer. I've put a little diagram here to remind you that we were up in the application layer at the very top during going through all of those protocols. But now we're in the transport layer, which has to do with segmentation and transfer of data. The two protocols that we're primarily concerned with here are TCP and UDP. Extremely important protocols. Why? Not only because they often come up in interview questions, they do, but why do they come up in interview questions? Because it's part of the basics of networking that you need to understand. So I do want to say here, the TCP IP model that we're studying here keeps both segmentation and transfer of data in the one transport layer. The OSI model, which we're going to look at later, breaks the segmentation out into a different layer. But right now, just focus on the TCP IP model. Associate transport with TCP and UDP. All right, what is TCP? TCP is a protocol that has all sorts of nifty, yes, nifty things that it does. So TCP, packets are all split up. So when you communicate with a web server, it's not just one continuous string of zeros and ones, okay? Those zeros and ones are split up into different packets. And that does a lot of things for us. It allows other people to communicate on the network while you're using the network. That's one of the primary things. But there's some problems with it because the packets might get to the web server or even come back to you out of order. But TCP takes care of numbering the packets for each session. And so, if packet 1, 2, 3, 4, 5 are sent and received as 1, 3, 4, 5, and then 2 comes later, TCP reorders them. Or maybe something went wrong along the way, and maybe packet number 4 was dropped. TCP will send a message back to the sender that says, hey, I didn't get packet 4. And then the sender will resend packet 4, and TCP takes care of putting those back in order. So it does lots of things like that. It also does a thing called windowing. Windowing is like, it'll say, okay, so it's sending certain size packets and maybe the server isn't that busy. It'll send back a message that says, I can have a larger size packet. So send me larger packets, and the sending device will switch and start sending larger packets. Or maybe it's, a fireworks store and it's 4th of July, and it's getting a lot of action on that web server and needs smaller packets. It'll say, oh, I'm not able to process all this data. Send me smaller packets. And the key with TCP, all of those together, they make it a reliable delivery service, right? It's reliable. You know that you sent the packets, or your computer knows it sent the packets, and it knows that through TCP, if something goes wrong, it's going to get a notification back. Okay? Reliable. Now, if you can imagine, that takes a lot of talking back and forth. And sometimes you have a protocol that where time is more sensitive than making sure every packet is delivered in order, right? And so then the UDP protocol is used, and UDP protocol is best effort. Like if a packet gets there out of order, oh well. Or if one of the packets doesn't make it, right. So no, there's no process for sending information back with UDP saying, oh, send me another packet or keep these packets in order. No. Here's maybe another way to think of this that might be helpful. Like here you go to the doctor and you've got something wrong. You say, when I hop on my right foot 3 times to the left and then I sit down slowly, my elbow hurts. And you want your doctor, medical provider to listen to you, right? And say, now, have I got this right? When you hop to the left, to the right, you want your doctor to communicate with you. You've got something wrong. You want to find out what it is, and you want the doctor to pay attention and communicate. Okay. But let's say you're just bleeding to death or something. Do you want a lot of communication to take place? No, you want the best effort to stop that blood. Maybe this is too gory. I don't know. But sort of the difference between whether a TCP protocol is used for an application or whether the UDP protocol is used for the application. If it's video streaming, UDP is going to be used because it's more important to have some speed and not a lot of communication. But when you're contacting a website, TCP is just fine and it works great. Okay, so TCP, what is it? It is reliable, reliable. And UDP, what? It's best effort. And what layer of the protocol stack do TCP and UDP belong at? At the transport layer. That's right. You got it. I hope you got it. All right. So here we are at the internet layer. We're moving down the stack. Application layer, transport layer, internet layer. Now remember I told you at the application and transport layer, I wanted you to kind of memorize those protocols. Here at the internet layer and down at network access, I just want you to create a familiarity with what we're going over. We'll go over this even more in the next video when we examine the OSI model. Okay, so internet layer is connectivity between different networks. That's the key here. We have IPv4, IPv6, NAT, network address translation, and our routing protocols. Some of those are OSPF, EIGRP, and BGP. By the way, this is one of my favorite layers. I think it has the most interesting protocols. It's fun. It's so fun. Now, when I say a different network, so like you're working and you're on a network and you want to go to google.com, that's a different network. It's not on your network. It's not inside your house or your building, wherever you're working. It's a different network. So we have protocols that specifically work to get your packets to that different network. And that's what we're talking about here. Okay, moving on. The network access layer. This is, your basic local connection to the network. So if you unplugged everything from the internet, could you still communicate with other devices on your local network? Like if you have a PC and another PC and they go through a switch, or if you have a PC and a printer, your local network connections. What are we concerned about on your local network connections? Well, I'm going to go into more detail later when we cover OSI model, because this is split up a little differently on the OSI model. So that's why we're going into detail there with it. But ARP, address resolution protocol, it's here at the network access layer for the TCP IP protocol stack. MAC addresses are here. I'm going to cover those in more detail in OSI model. Your network interface card is located here. Ethernet, wireless. So if you're plugging in with an Ethernet cable, like I have shown here in this gigantic picture, Ethernet or wireless, that's covered here at the network access layer. You can see we have the wireless NIC, network interface card, that would be plugged into your motherboard. Wireless NIC. And then it has some antennas that are separate. That would be here at the network access layer. If I were to order this from Newegg or Amazon or somewhere, this network interface card would come already with a MAC address associated with the network interface card. Every network interface card comes from the manufacturer with its own MAC address. It's the MAC address, and we're going to cover it in more detail when we do the OSI model. And then we also have ARP at this layer, Address Resolution Protocol, and that is the way that the MAC address is mapped to the unique IP address on the network. So many protocols, so little time. What do you need to remember about the network access layer at this point in time? So you should remember that it's concerned with the local connection, MAC addresses, what type of medium that you're using to connect to the network, be it Ethernet or wireless. And I mean, phew, we're to the last slide. Thank goodness. That was a lot of theory, and I mean a lot. I hope you made it to the end. If you're one of my students, it's all going to be on a test next week, so you gotta make it to the end. So in this marathon presentation, we covered encapsulation and de-encapsulation. What we did is I went through the application and transport layer. I want you to memorize the information that we talked about in those two layers and the protocols that are in those two layers. Some of the protocols received more of an explanation than others because we're going to discuss the other ones in the next video. All right, so that was the lecture for Module 3. Wait, that was half of the lecture for Module 3. Now we're going to go into the OSI model and cover the other half of the lecture for Module 3. So, yep, we're going to take a closer look at the lower layers. We're going to look at how the OSI model is different and how it is the same. So compare and contrast from the TCP IP model. And I hope to see you in the next video. Even if you're not part of my captive student audience, I hope to see you in the next video. All right. Have a great day. Bye-bye.